We're talking about solving systems of equations. There are two methods that get discussed in textbooks, and I honestly wish they wouldn't do them because for different reasons, they're just unreliable. Okay, so the first one is this method of what's sometimes called finding a numeric solution. And what they mean is I've got a system of equations here, right? And just to keep the y values different, I'm going to call this one y1 and this one y2. So the way this method works is you pick numbers, right? I'll pick 0 for x. And if I put 0 into the first equation for y, it's 4 times 0 plus 1, which is 1. And if I put that into the second one, it's negative 2 times 0 plus 7, which is 7. Well, those numbers aren't the same, right? So this is not a solution. Then you just kind of keep trying, right? You try, well, how about 1? 4 times 1 plus 1 is 5. And negative 2 times 1 plus 7 is 5. There we go. We got the same number both times. All right, so that tells me that this is my solution. The point 1 comma 5 is a solution to both equations. Now, that may seem like, I mean, we happen to get it very quickly, but that was luck. Okay, that was luck. If the x coordinate of the solution had been 5, we'd have been here for a little bit. And if the x coordinate of the solution is 4.25, we could be here quite a while picking random numbers until we just happen to get lucky and landed on the one that is actually the solution. Right? So that's really my big reason for disliking this method is that it's based on luck. And even if luck is on your side, it really only works well when the solution happens to be nice. If the solution had been 1/3, then the decimal would have been 0.33333, and you're in a whole different kind of trouble. All right, so this is not a method that I really recommend ever relying on. The second method that I really wish textbooks wouldn't mention anymore is the idea of a graphical solution. All right, so with this method, what you do is you graph the two equations, and then you look at the graph and you say, well, it looks like the two lines are crossing right here. The coordinates of that point are over 4, up 4. So the solution is 4 comma 4. Well, okay, maybe. In this case, that's not the solution, and I know it's not the solution because I very carefully I came up with the equation. I started with the equations, so I knew what the solutions would be. The solution here is actually 4.01 comma 3.99. Now, obviously, you can't see that. You can't see at that level of detail, that level of precision with a graph. I always tell students, anytime you're dealing with a graph, anytime you're trying to infer something from a graph, your answer is inherently inaccurate. It is inherently nothing better than an estimate or an approximation, which is why, again, I really discourage people from using this method, except in the very weird situation where for some reason all you have are the graphs. But those aren't things that really come up in algebra. We always have the equations. And when you've got the equations, using the algebraic method, the substitution method, the elimination method, is always going to be, you should always be your first choice because those methods will always give you the exact result.